Okay, so completing the square we've done before. And where did we do it before? We did it when we wanted to make an equation from this to this. Okay, that's where we did it, last unit. Okay, so remembering that process, we kind of wanted a trinomial that made that perfect square piece, right? That was kind of the part that was to complete the square part. Okay, so here's what's different between what we did and what we're going to do. Do you notice how this equation has a y in it? Today, we don't have a y because y is worth 0. Okay, so that's different. So before, we had to keep y in there and leave it as an equation with 2 variables. But now that we have no y, we're going to work to isolate our x today using that process. Okay? So I'm going to tell you that I've never used this as a math strategy. Okay? Guess why? Do you think a formula, the quadratic formula, does the exact same thing? Way easier, right? Formula is just plug in. Don't have to think about anything, right? Okay, so you have to know this process. So on the test, you're only ever going to use it when it says complete the square. Okay, otherwise, it does the same thing as the formula. So if I just say solve something, I really wouldn't pick it as the method to solve. Okay, here we go. Move the number over. Okay, this is all kind of very similar. Move the number over. Okay, so before we had the y part in there, and now we don't. Okay, step 2, complete the square. I did something and then something. You remember the 2 things? Half squared. So half of the 4 is 2. 2 squared is 4. So there's my trinomial that I want. But what did I do? I threw that onto the side of the teeter-totter, so now I have to bounce it back. Okay, so the purpose of this trinomial was what can I FOIL twice like that to get there? So do you remember the relationship? It's always going to double there and square there because the FOIL makes a double, O and I, double it, add. So what adds to the middle and multiplies to the end? Okay? But really, it's always doubling and squaring because it's always doing that. Okay, now, what's another key thing we've learned? If I had something like this equation, x squared equals 25, what's the answer to that equation? Plus or minus 5. Okay, so this is also important today. Okay, and you've noticed how often we've solved stuff. They almost, not always, but a lot of the time have 2 answers, right? Okay, so here we go. How am I going to get x alone? So I'm going to square root both sides. Does that make sense? And I get x plus 2. Tell me what you did here. You square rooted both sides, but your answer could have been a 5 or a negative 5. So I'm going to go a plus or a minus, and then does the square root of 17 work out nicely? No. So you know what I would do? Leave it. Okay, I'm not going to leave square root of 25 because that works nicely. And then, how do I get x alone now? Okay, so you have 2 answers. If I was to talk about, I want you to leave it like that, but if I was to talk about it as a decimal, Do you know how to get me a decimal answer? You would have to do what in your calculator? The square root of 17 and then subtract 2. It's 2.12. How do I do the other version? Because there's two answers. So I would do negative root 17. Do you notice how I wrote it in the front? Okay, I can't write it inside the square root because that would make it impossible. Subtract 2. Do you guys know your calculator buttons? This is negative and this is subtract. They're two different buttons, right? Okay, but I do want you to leave it in this form. Okay, but this is, if I did it in the quadratic formula, that's what I should be getting, right? You don't write this down, but here's me checking. Okay, so here's somebody who solved it with the quadratic formula. Remember that was yesterday's stuff? Look, there's my answers, right? So that's why I say if there's a choice, I'm not picking complete the square. I like the formula better. Okay, but you do have to know the process. Okay, here we go, a little faster. Ready? Move that out of there. Move that out. And now, can you make yourself a trinomial? What do you want your simple trinomial to end with? It's always plus 25, half squared. Balance it out. What do you FOIL to get that trinomial? So what is going to multiply to that and add to that? When it multiplies to that and adds to that, it will do double and it'll do square. Next, you're going to square root both sides so that you can get rid of the squared. And I'm not going to forget about this having two answers to it. Okay, how's that? That was a simple trinomial. So the last two bottom ones are going to be complex ones. Okay, so when we did this before, when we had the complex, we factored it out, okay? Because when we did our equation, it was important that it was still in our equation, because the slope was important to keep in there, right? When I'm solving for an x-intercept, I don't need to keep it in there, right? Because I'm trying to just eventually isolate x and get rid of everything. Does that make sense of the difference? Before we kept it because it was an equation, now I can get rid of it. So that's actually what I'm going to do. Divide by 4, divide by 4, divide by 4. Divide by 4. Everything, right? When you do something, it's like giving kids candy. X squared. Subtract 4x. Are you guys okay also if I move that at the same time? Kind of doing two things at one time, but. Okay, good. So move that over, but and I'm also dividing to make it a simple trinomial. What do you want to end the simple trinomial with? So this is half squared plus 4 So I'm going to plus 4. What squares to make that trinomial? So what times this to that and adds to that? Okay, you're not going to get scared here, but we're going to do some fraction math because on your test I'm going to tell you you can't do it as a decimal. I want you to leave it as a fraction. All right, so what I'm going to do here is I'm going to put my 4 as a 4 over 1. How do you add fractions? What's the concept behind adding fractions? Common denominator, right? Would you be okay if I had to turn this bottom into a 4? So I'm going to turn it into a 4 by multiplying by 4. So therefore the top would turn into a 16, which would make 31 out of 4. How do I get x alone? I should square root on both sides. Plus a minus again, because I could have, what can square to make something? You could square something positive there, or you could square something negative there. Did you notice how I have this whole fraction inside my root? So if you wrote this, you're wrong. If you wrote that, it's wrong. Do you see a difference in mine? That one?
Would you take 7 3/4 also?
I would. You just did more work, didn't you? Because you're touching your calculator.
Oh yeah, I did do that. Yeah.
You're just doing more work that way. Okay, does everybody see why that person wrote that one wrong? They're square rooting 31, but not 4 here. Okay? You know what is correct? Oh, this is actually correct if you wrote that. Huh? Do you see where I got that one from? Because I can square root 4 and I can make that bottom just a 2, but with no radical, right? Okay, but that's kind of where you should go. Okay, here we go. So I can already start the isolation process. And I did mine 2 steps in one here. I'm sorry if you, are we okay, me doing those 2 steps at one time? Do you understand my positive negatives going on here? Do you see this number here is positive? Do you see that? Negative, negative makes positive. So that's why I'm over here now negative, right? Okay. So here we go. Complete the square. Half squared makes a positive, always 9. Balance it. What squares to that? So what multiplies to the end and adds to the middle? Okay, we're doing fractions over here and we're not touching calculators. Okay, I'm going to put 9 as a 9 over 1. So let's change to a bottom that we like. So I'm going to make this bottom 3, which turns the top into a 27. So what's negative 7 plus 27, or 27 subtract 17? 10. Okay, and then finishing it out, how do you get x? Well, you got to first get rid of the squared by square rooting. We're going to always remember we could have squared a positive thing or we could have squared a negative thing to get there.